Question 2, and we're on to impulse. We have been given an impulse in vector form, and we have also been told about the final velocity of the ball. Now this impulse is on the ball, and as the impulse is on the ball, I'm thinking about the change in velocity of the ball. So my impulse equation is m lots of the final velocity of the ball minus the initial velocity of the ball. Now I'm talking here about vectors, so I should have the vector impulse and the vector velocities. This tells me that minus 5 plus 3j is equal to 0.4 lots of 12i plus 15j, subtract the initial velocity of the ball. Divide through by 0.4, that gives me 12.5i, 7.5j is 12i plus 15j minus my initial velocity, and then rearranging I find out that minus 24.5i minus 7.5j is equal to minus my initial velocity, and multiplying through by -1 tells me that 24.5i plus 7.5j is equal to my initial velocity b. Now I have to be careful because this isn't actually what I was asked for. I was asked here for the speed, and what I've got here is a velocity, so I need to now change this velocity into a speed. So 24.5 squared plus 7.5 squared square rooted gives me my final answer, which is 25.6 meters per second. For the second part of this question, I really do need a good diagram to help me out, because I'm thinking about a deflection angle, and these are really difficult to visualize without a decent diagram. So the first thing I'm going to do is I'm going to draw my initial velocity looking something like this, because we were moving 24.5 in this direction, 24.5, and 7.5 in this direction, 7.5, and then I'm deflected, so we're deflected off this course, so we're not going to continue travelling in this direction because we've received an impulse that's going to change our direction of travel. And that change in direction of travel takes me to 12i plus 15j, so I'm sort of travelling somewhere like this, where the bit across the bottom is going to be 12, and the bit up the side here is going to be 15. Now what I'm really interested in is by how much has my journey been deflected. So my original journey was going to be travelling straight along here, but I've been deflected off that course. So I've been deflected round by this angle here. How am I going to find that? Well, two angles that would be very easy to find are this angle in here, which would be tan inverse of 15 over 12, and another angle that would be very easy to find would be this angle in here, which would be tan inverse of 7.5 over 24.5. How does this help me? Well, because the red angle down at the bottom is exactly the same as the angle in here. So if I subtract my red angle from my green angle, I end up with my blue angle, which is the angle of deflection. So popping this into my calculator, I find out that the green angle is 51.34 rounded, and my red angle is going to be 17.02 rounded. So my angle of deflection is going to be the difference between those two, so 51.34 minus 17.02, which gives me 34.3 degrees.